I think it's nice to be able to travel without a visa, you know.
I think the EU is good for the poor countries and bad for the rich countries.
That is true. Yes, that's probably true. It's probably good for places, small countries. Maybe not so good for France, Italy. It's good for Germany though.
Why?
Because Germany export, export? They export a lot to Europe. So having no tax, having free trade means they can export all their cars to, France and Italy, things like this. So Europe is really good for Germany. Some people say too good, maybe. I think maybe they're right.
Did they invent the EU, the idea?
Germany and France, yeah. I think more, Germany and France were like original too, yeah. Although I think it was more, maybe more American idea.
For Europe?
Yeah. Because it was after World War II. America had a lot of responsibility in shaping and rebuilding Europe.
Yeah.
So they had lots of plans, So I think one of their plans was more united France and Germany, So I think America was very important for the way Europe is now. American influence is dominant everywhere.
Yeah.
Everywhere. All the world, exactly. Even Europe still. But that's probably decreasing, I don't think America's influence is as dominant maybe as in the past. You know what I mean? Maybe China, Russia, maybe.
No, because America did what all she wanted to do. No.
Huh?
Now she wants to watch only. Like, they did all the things that they want.
You think so?
Yeah.
Maybe. It's complicated. It's very complicated. So you said Iad is coming in the second class. Did you see Mir yesterday?
This he came in the physics class. And
That you didn't see. Okay. Let's see what we have to do. Histograms. You got that? So this again, not on the syllabus. But but something like it is on the syllabus. So you still need to understand what they are, So we'll have a look now at histograms. And I might ask you to do one example. Door's locked. Adnan or Mir? Who do you think? Adnan or Mir?
Adnan.
I think Mir. No, Adnan. We're wondering if it'd be you or Mir.
Yeah.
Oh, you did? I was just saying to Musharif that I still want you to do some of these, even though they wouldn't ask you to draw them on the exam. So, let's have some data. And I'll put the data in the table. You don't want to write this down?
Yeah.
Okay.
I don't want to understand it.
Okay, fine. So here's X and here's F. So we'll go, this could be heights of something. So 0, well, do you know what? I'll put it in centimeters. 0 to 9.5. 9.5 to 10.5. 10.5 to 19.5. I'll only do 3, so this is our data. Maybe these are heights of a plant or something. Whatever. So, let's imagine we have 3 plants that are between 0 and 9.5 centimeters. Let's say we have 5 plants that are between 9.5 and 10.5. And then let's say only 1 plant is between 10.5 and 19.5 centimeters. Okay, so a histogram is a way to represent this data on a diagram. So to calculate it, you need to calculate another column called widths. So on your table you would write above these how wide they are. So this one is 9.5 wide, this one is 10 wide, and this one is 10 point, oh yeah, sorry, I made a mistake there. I shouldn't have
19.
I should have meant like 19, yeah. And this one could be 19 to 29 then, thank you. So this one is 10, and this one is 10. They do not have to be the same. Don't have to be the same. It's better if they are, but they don't have to be technically. So these are the widths. And then underneath that we calculate something called the density. And you know density from physics. It's, what, do you remember what it is? Yeah, mass over volume. But in this case, it's not mass over volume. What do you think it is? There's only 2 things. So, is it x over f or f over x? We're going to have 2 choices.
F over x.
Oh, you were right the first time. X over f. It's height per plant. So the density here is 3 over 9.5, 5 over 10, 1 over 10. So, I don't know, can you calculate that please? I know this is 0.5 and this is 0.1 and this one is about, well actually that's 6 over 19 over 9.5.
0.31.
0.31? 31?
5. 7.
So 316. Yeah. Yeah. Okay, so what we need to make the histogram diagram, we need to know these and these. So before I draw it, I'll just give you a minute to write this down, okay? This is example. Okay, do you have this written down? 1 minute, okay. Yes? Okay. So a histogram, we can draw it now, is a bit like a bar chart. So what you do is, on the x-axis you put your data, which in this case is x in centimeters, and on the y-axis you put the density. So we go from 0 to 20, so that's 0, 10, 20, 30, 25, 15, and 5. I should really have my 0 at the beginning, as is normal. Let me just move this. Okay, and you can see the density, the highest value is 0.5. So we'll go up in 0.1s, 0.1, 0.2, 0.3, 0.4, 0.5. And we draw bars. The first bar is 0 to 9.5, 0 to 9.5, and it goes as high as 0.316, so that's about to here. So this is the first bar. Second bar goes from 9.5 to 19.5, so that's about here, and it goes up to 0.5. So that would be to here. Close enough. And then the last bar is 19.5 to 29.5, and it goes up to 0.1. Like this. And this is the histogram. Now, using our physics knowledge, we can work out what the area represents. So what's the unit here? Centimeters. And the unit here? If you look at the formula for density, what was the formula for density?
Centimeters over
frequency. Yeah, the unit is centimeters per frequency. Yeah. So here is centimeters per no, sorry, I said that backwards, didn't I? Frequency per centimeter, because we had the F over the cm, the data. So what is the area here if you multiply these units together? Frequency. So if you calculate the area here, you should get 3, 5, and 1. So the area equals the frequency. Let's test it. Here to here is at 9.5. Here to here is 0.316. When you multiply them together, you do get 3. Let's do an easier one. Here to here is 10 units. Here to here is 0.5. 10 multiplied 0.5? 5. So the area on the histogram represents the frequency. Why is that useful? Well, it means you can now answer questions like this. If I look at this data and I said, how many plants were between 9.5 and 19.5 centimeters tall? You would say, 5 plants. How many are between 19.5 and 29.1? You would say, 1 plant. But suppose I ask, how many plants are between 15 and 19 centimeters? Is that on the table? 15 to 19? No. But if you go to the histogram, you can mark off 15, you can mark off 19, you can draw the shape in. Sorry, that's not quite 19. 19 is about here. And then the area is the frequency. So let me see, how big is this one? We said 15 to 19, so this is a 4, and this is a 0.5. So this area here, 2. So the answer is, there are 2 plants between 15 and 19 centimeters. You couldn't answer that question on the table. but you can answer it using a histogram. And also, what does the total area equal to? If you add them all up, you should get the total number of plants. You should get 9, and of course you do. So the total area is the total frequency then. So these histograms are extra important in the next chapter. I'll just have you draw this one down as your example. Yeah. I wonder if I can make this a bit bigger. That's better. You drew this, Musher? Yeah. Adnan? Sure. Yeah? Okay. I'll scroll down. So, okay. Let's see. Example. So I will give you one to draw for me. And what data will we use? We'll use a mass or something. The mass in grams of something. Frequency. Okay. Now, 0 to 2, 3 to 5, 6 to 8, 9 to 11, 12 to 14, 15 to 17, 18 to 20, 21 to 23. Before you start, just so you know, if you look at something like, let's take this one as an example, 3 to 5 grams. What is the biggest mass that could be in this box?
5.
Not 5, because actually it could be
5.5,
yeah. And the smallest one?
2.5.
2.5, yeah. So just be careful, because the width is not actually 2, the width is actually 3 units. So these are all 3 units wide. And when you draw the bar, this bar, for example, starts at 2.5 and it finishes at 5.5 as an example. Also, I didn't say this about histograms, but this is very important. One big difference between a histogram and a bar chart is there must be no gap, no space between the bars here. So that means when one box finishes, the next box starts. Do you understand? Are you sure? You look sleepy. Are you not? Okay. Draw, please. Draw beautifully. The music will help you draw.
But the ground is gonna start from -half.
Very good, yes. Yeah, now see, the context is important here. Because they're masses, you might say -1/2 doesn't make sense because you can't have a negative mass. I think we could do either. In fact, it actually doesn't matter because you have 0 in this box anyway, so I suppose technically you could say the mass could be negative because what this represents is not the mass, but the mass that you measured, and if your machine was not correctly calibrated, then the mass might read out as negative on it. You know those digital scales, or not even digital scales, you know the old-fashioned scales with the dial on it? No, the one with you put a mass on it and then the dial moves. Yeah. If they're not calibrated correctly, if the mass on it is really light, there's a chance that the dial might actually go backwards a little bit. You know, but then if that happened in an experiment, then you should really think I'm doing something wrong here because the mass. It's negative. So, your call. What would you think? Include or not include?
Include.
I include zero as a bar.
You can't, it's just a flat line. You'll come back. You're not going to abandon us, are you? Oh, great. You'll come with extra. Finish measuring. You drew the chart? Let's see your picture. You made a mistake. It's the wrong shape. You made a mistake. Something's wrong. Something's wrong with your heights, your density.
F over.
Yeah.
Or F over C.
Yeah.
0 over 3, 0.
Yeah. Next.
1 over 3.3.
Next.
3 over 2.
No. What?
1.
Why 3 over 2?
2 over 3.
Yeah.
So the F2, when F is 2, I don't know.
Yes. Correct. We have to fix it. Fixed. Let's see now. Yeah, let me see. Beautiful. Now, let's have a look here. Here we go. Okay. Musharif, I'll just have you do one question from the worksheet and then we'll take a break. So do you see the one up the top with the volume? I just want you to draw the histogram for this and then we'll take a break, okay? So volume in milliliters and frequency. Can you see it okay? No, too big now. This one. And in the second class, I'm sorry to tell you, but we're going to do physics. I am a little bit behind in physics, just a tiny bit. I feel like if I change one math class to a physics class, then the two of them are back together. Because I want to finish at the same time for both. You know. Do you have your physics book with you? Oh, okay. Well, you can copy it in later. Did you get the extra person as promised? What happened to you? Just good old-fashioned sleepiness, is it?
No, I woke up very early.
Oh, really? Okay.
Yeah.
So good old-fashioned what? Okay. Okay. Good old-fashioned personal situation. Okay, alright. Adnan, I'm just having you draw the histogram for the first table there, and then we'll take a little break then. volume in milliliters is the data. Couldn't find mirror on your way out, no?
Mhm.
Finished? Can I see? Did you write in X and Y? What's on the X and what's on the Y?
Volume,
And the units for volume?
mm.
And on the X?
And
So what's the symbol for density?
frequency.
No, it's symbols.
I don't.
Oh, did you? Show me. Where'd you put it? Oh, yeah, okay. Good. Adnan, you're drawn?
Yes.
Okay. I was saying to Musharif, we will do physics in the second class. Because I feel like I am one class behind in physics, because the next chapter here is the final chapter. And so I would like to finish the fields chapter in physics at the same time as finishing this chapter. I think it'll be better. Calculator, Adnan?
Mhm.
Do you have a Casio?
Mhm.
Okay. How are we doing here? Adnan, what part are you on in the graph?
The
You're-
volume.
You're calculating the densities?
Yeah, I have. The volume, should I start with the first one? The first number, 302, and then increase by 10 and divide all of them?
Yeah. 10 from 302 should do it. Yeah. Okay, you can take a break for a couple of minutes. Then we will do the next physics lesson.